Hi everyone, my name is Namir Mahdi. I'm going to present our project Wireless Electricity for Laptops. We have in the group Mengyang, Amjad, Yizhuan, Kang, and Faizan, and our supervisor is Dr. Alan Wang. Initially, in the first 5 weeks, five projects were proposed on the tables, and these projects were the first one was Dress Choice app, which was basically to an app that assists people to select clothes whether according to weather occasion, and you can shake it to get dress collection. The other project proposal was basically a smart swing, and where you put the child and then there's a sensor that will start swinging based on if the child is crying or not. The third proposal was electronic oil tank, which is basically an electronic oil tank for the car, and it saves money, environment friendly, easy, clean, and safe to use. There is the auto bath, which a user can set temperature. The user is able to also set the duration, and they can also set their time. From here, we also proposed project by two of the members were wireless electricity for mobile applications. And basically here we have the idea of wireless electricity. You have a source coil which transmits fluxes all over the place, and then you have the receiving coils, which in this case could be a lamp, laptop, or even a phone, and then without any wires, without anything. So the project need is basically there is no need to have your laptop, your charger or your cable with you anytime. Then from there we did our project specifications, and basically we proposed two design. One where the transmitter circuit is just below the table, and one where the transmitter circuit is just here. The reason we had two different designs is basically in case we cannot fix it down here, then we can put it here, and the transmitter circuit should be able to maintain within a height of 0.6 meter. So these are the important specifications that we're proposing, and basically the input is what comes from the socket outlet. Output is what goes to the laptop, and transmitter size, we're trying to make it as small as possible. Receiver size is proposed to be 10 centimeter radius, efficiencies 75%, temperature and humidity. And then from here we did the SWOT and risk assessment, and to analyze further the project. One of the important things about strength to note here is the improved connectivity, where people can have access to their computer or mobile applications without having to have their cable connectivity with them. As for the weaknesses, important things to note here is the low efficiency and the high losses. That is because fluxes are generated in the air, and that has a direct proportion into uh, money and how much expenses might cost. From there, we looked at the threats, and the main threat here would be budget constraint for integration. So basically, having a receiver circuit as part of the laptop, for example, not many companies would go for that change to change their design. And then the opportunities is things to note here is it's a new and innovative technology, and also there's a low cost for large scale integration, which is really good. Then we looked at risk assessment, and basically the main one was electricity when dealing with this project, and which has a risk of electric shock. And then we have electromagnetic radiation generated by the fluxes, and you have fire from overheating in the receiver circuit or even the transmitting circuit. You have ergonomics, which comes from a lot of testing that needs to be done for this project, and then sharp objects and wires in the lab. From here, we build our technical drawings and block diagram, which basically we have input, conditioning circuit, transmitter circuit, coil, and this whole thing basically represents the transmitter circuit. And the transmitter circuit is proposed to be, so this is the conditioning circuit, which is a resistor and a transistor, and then we have the coil. From here we go to the receiver circuit, which is basically you have the coil, rectifier and filter, and DC regulator. And from here we designed the rectifier to be rectifier bridge, and normal voltage regulator in this case. We did simulation, and basically our simulation is this is what we did. This is the receiver coil, which is made of LED, and this is the transmitter coil, which is made of a coil, resistor, and transistor. And basically, you can see that if it goes up, goes down, then the light goes on and goes off. So there's the limitation in the distance. And then if it goes right or left, still the same thing. Now, the equipment that we need for the lab in order to do our project is AC power input, resistor, NPN transistor, rectifier and filter, DC regulator, and cables. And from here we got our project cost, which is up to the budget. So we have the coils, rectifier, resistor, and amplifier. Now, to recap and sum what we did for the semester is basically we did research in wireless electricity. We proposed specifications for the project, and then we did design of final circuit, which is also in progress. Then we did SWOT and risk assessment, which finally we did the mini prototype and the simulation. Now our current objective is to build a wireless transmitter and receiver circuit according to proposed specifications. Our future plans is to order component by week 14. Then from there we build the wireless power transfer circuit. After that, we run tests on the circuit and try to improve on it. And then once the tests are done, improvement are done, then we construct the final product, which is according to proposed specifications. And before we rolling it out, we run final tests to ensure that it meets the required function that it is designed for. There are a few mistakes that our team has encountered in this semester and that we should address so that we can get some reflections on lessons learned so that we don't repeat them in next semester. One of the main problems that our team have faced this semester was the lack of effective communication between each member in the team. In terms of weekly meetings, it was really difficult for the team to meet everyone at the same time, as people had different commitment and personal life that they take into consideration. So that was not an easy part, to be honest. As an example, the first meeting was only scheduled after the end of third week, and it was not very effective as there was no agenda, no planning, nothing at all, and one of the team members was actually left behind. In terms of communication tool, apart from face-to-face meeting, we also employed social media applications such as WhatsApp to share information and offline communication between each other, which was really a good idea to establish such a group in social media. However, in some instances, the meaning of the message seems to be unclear and was interpreted in a different way, and that had some impact on the progress of the project. As a learning from the mistake, we have created a fixed date and time for every week. We also make sure that we would have at least a couple of days before the team gathers so that we can brainstorm what we did in the week before, and so that everyone would be on the same page and keep the project flowing. Another mistake we made at the beginning of the semester was setting an unclear goal for the product. So initially we wanted to create a variety of applications for our product without looking at the constraints such as time and commitment that each member might have to do project research and development. Fortunately, after consulting with our supervisor, we've realized and learned that it is better to set SMART goals where they are specific, measurable, and can be achieved in that duration.
Created using Powtoon.